Hi everybody, welcome back. Today we're going to be talking more about functions. Instead of looking at a table or a graph to figure out different values, we're going to be looking at equations. So when we're talking about function notation, traditionally functions are referred to by the letter F. So functions are typically referred to by the letter F. However, if we kind of think about it, if every single function had the letter F, we would never know how they're different. So that's why you see things like an F with parentheses and an X, a G with an X in parentheses, and so on. The way we say this, so if we're looking at F parenthesis, X parenthesis, we call that F of X. The G parenthesis X is G of X. The H one would be H of X. Go into the M's, we have M of A. And then the A would be ace of T, is the way we pronounce these. So looking at the first one here, kind of think as what we're doing as a little machine. Our machine is the equation. We have either inputs or we have outputs. And as we've said previously, inputs are referring to the letter X. That function notation, such as f of x or g of x or whichever, is our output. Another way to look at outputs are our y. So when we put a number in for x, what does that machine spit out for us? So if we look at example number 1, it says evaluate f of x is equal to negative 3x minus 10 for x is equal to 6. It's telling us that x is equal to 6, which means that any place I see x in my equation, I want to put a 6 in its place. So it's not just f of x, now it's f evaluated at 6 is equal to negative 3, not negative 3x, but negative 3 times 6 minus 10. So again, because it tells me x is equal to 6, I simply take x out and I put a 6 in its place, following whatever operation is there. So f of 6, that's just notation. It's saying the f function evaluated at 6 on the graph. What number does it match up with at y? So that's equal to negative 3 times 6 is negative 18. Good job. Minus 10. Negative 18 minus 10 is negative 28. So my function f evaluated at the number of 6 is equal to negative 28. How would that look like on a graph? Well, it would be the point 6 comma negative 28. So we have our x and we have our y. So that's kind of how this all relates together. Let's try another one. So if you look at example 2, it says find g of 3 for g of n is equal to negative 2n plus 3. So if you notice here, I have a 3 and it's in the n position. Do you all see that? My 3 is in the n position. So what it's telling me to do is take out the n and put a 3 in its place. So I'm going to rewrite my equation. Instead of saying g of n, I'm going to say g of 3 is equal to negative 2. Instead of saying n, I'm going to say negative 2 times 3, and then I still have that plus 3 in the n. So again, because that 3 is in n's position, I'm putting that in n's place in my equation. So now I can go ahead and simplify. What is negative 2 times 3? You guessed it, negative 6. I still have that plus 3 in the end. So negative 6 plus 3, good job, negative 3. So my g function evaluated at 3 is negative 3. So again, if we're thinking about a graph, how that would look on a graph, well, if you look at the x line 3, it would match up with negative 3 on the y's. So again, tying back to what we did in the previous days. Looking at number 3, I have j of x is equal to 1/2 x plus 7, and it tells me x is equal to 4. So it's telling me what x is. So I'm going to find where x is in my equation, and I'm going to put that -4 in its place. Be careful with your signs. So instead of saying j of x, I'm going to say j of, you guessed it, -4, because that's what x is equal to 1/2 times, instead of timesing x, it's going to be times -4, and I still have plus 7. Again, on the left-hand side, that j of -4 is just telling us this j graph evaluated at -4. So what is 1/2 times -4? Another way to think of it, what is 1/2 of -4? Good job, -2. Plus 7. I still have that plus 7 in the end. What is -2 plus 7? Awesome, 5. So that tells me that j evaluated at the value -4 gives me 5. Final one like this. Number 4 is saying evaluate h of t equals 6t minus 10 for t is equal to -3. I know some of you are thinking, how is this different? It's not any different at all. I'm telling you what t is. You put t in for t in both parts of the equation. So my function h evaluated at -1/3 is equal to 6, instead of times t, what is t again? Yeah, great, -1/3. And I still have that minus 10. So again, I'm taking t out and I'm putting -1/3 in its place. Now I know some of you are probably getting confused at this point, thinking, how come we're not multiplying h times -1/3? That's not a multiplication problem on the left-hand side of the equation. This is simply just a label. It's nothing more than a label. So now looking at the right-hand side where I'm going to do all of my work at in this situation, I need to do 6 times a -1/3. So 6 times a -1/3, if you kind of think of 6 as a fraction, 6 times -1, we have 6 times -1 is -6. 1 times 3 is 3. So what's -6 divided by 3? That gives me a -2. Another way to think of it, what is 1/3 of 6? 1/3 of 6 is 2, but there's a positive and a negative, so one of them has to be negative, the answer. So I have -2, I still have that minus 10. If I'm down 2 in a game and now the other team just scored 10 more against me, I'm now at a -12. So the h function evaluated at -1/3 is equal to -12. So going back to how we were talking about points, the way that would look as a point is -1/3, comma, -12. Again, x and y. So in every one of these first examples that we've done, we were given x, or we were given our input value, the number that we put into the equation to spit out a specific answer. If we flip to the back side of our notes now we're going to be given the output value. And we have to figure out what number can we put in to get that output. That's the way to think of it. So if I rewrite this equation to start with, I have w of a, and that's equal to -4a plus 3. The other piece of information I'm told is that w of a is equal to a -1. So that means that wherever I see w of a, that's the same thing as -1. So I'm not putting a number in for a in this situation. I'm taking w of a out of my equation. So I'm taking it out of the equation, and I'm actually going to put a -1 in its place. So remember, we said that w of a is equal to -1. So I took it out of my equation, and I'm going to put -1 in its place. Does this look familiar to you guys? Yeah, this is just a two-step equation that we're all capable of solving. So I'm trying to solve for a. I want to know what the value of a is that makes this true. So I'm going to start by minusing 3 to both sides. -1 minus 3 is negative 4. Good. And that's equal to negative 4a. Final step to get a by itself, you guessed it, divide both sides by negative 4. And so I get negative 4 divided by negative 4 is 1, and that is equal to my a. So thinking about a graph, this time we were given our y value, negative 1, and we had to go back and figure out what value of x matches up with that. So a 1. That's kind of where that came from. So let's go ahead and look at another one. I'm going to try to write this in a different color. I have w of a, and that is equal to 1 over 4a minus 2. And I'm telling you that the whole thing, w of a, is the same as 7. So again, I'm not given a. I want to know what value for a will make this true. So that means in my equation, I need to take w of a out, and I need to put 7 in its place. So I'm going to take a 7, and I'm going to put it in its place because I told you in the original equation that w of a is the same thing as 7. So now when I go through and solve this equation, this should look really familiar to both tests we've done and the quiz that we have done so far this year. If I have a minus 2, how do I move it over? You guessed it, we're going to add 2 to both sides. So 7 plus 2 is, good, 9. And that is equal to 1 over 4a. Then we said in order to get rid of a fraction, we need to multiply both sides by the denominator. So what is my denominator? A 4, good. Now watch your multiplication here. 4 times 9 is 36, and that is equal to my a. Thinking back to the point again, I was given my output, I was given 7, and what I had to go back and figure out is what letter for a will give me that output, so 36. Let's look at our other examples here. Perfect. We're going to go ahead and skip to number 10. Okay, so with number 10, the only big difference here is now our equation still has a fraction in it. So there's nothing really that crazy going on here. We just have to carefully watch our math. So if I rewrite my top equation, f of x is equal to 1 over 2x plus 2. I'm also finding out that f of x is the same as 2. Okay, so because those are interchangeable, I can take f of x out of my equation, and I'm going to put 2 in its place. See how they're both the same? And now I go ahead and solve. How do I get rid of that plus 2? I'm going to minus 2 from both sides. On the right side, we say it cancels. On the left side, what is 2 minus 2? Right, 0. So 0 is equal to 1 over 2x. Now we need to multiply both sides by my denominator. So times 2 and times 2. 2 times 0 is nothing, so it's equal to 0, and that is equal to x. I hope this is making sense to you guys. Some little notes that I think would be helpful for you to write down. If it says find f of x given x, if it has this notation, this is where you are just substituting. This is where we substitute and do the plug and chug. Okay, chug along, plug it all in, and we can use our calculators to simplify it. If you see the words find x, this is when you have to solve an equation. Feel free to go back and rewind if you missed any of the information presented. Otherwise, I feel like you guys are ready to start tackling your homework questions. Just remember, if it says find f of x given an x value, you're going to use substitution like we did on the front side of the notes. If it says find x, then you're going to be doing solving an equation like we did on the back side of the notes. So look for your key terminology, and that will benefit you more than anything else. I hope you guys have a fabulous day, and I look forward to seeing you all soon. Thanks. Bye.